Silo calculations, loads. In our last tutorial, we saved the geometry for our silo in Amphora, so now we can begin applying the loads. Let's get started. First, if you're still on the geometry page, you need to click on the loads heading to navigate to the loads page where you can edit the silo loads. First, we need to enter the type of medium. So this is for our own reference right here. Next, we need to enter a dedicated density. For each dry bulk medium, there are dedicated pressure and wall friction coefficients. We can enter them right here. Standard Amphora uses our default material factors, which actually covers quite a lot of them. But any other materials used should also have tested values filled in here or obtained from the EN 1991 standard. You also should enter the bottom load magnifying factor. If you need help with this step, you can click on More Info for a little bit of extra information. And lastly, enter the design temperature. For your reference, we've included a table of factors here from the standard. Next, the pressure. We can start by entering our design pressure and design vacuum. We can fill this in here and indicate whether or not it is short-term or long-term from the drop-down on the side. Again, we can add more, click on More Info here for a little bit of extra information. Note that if you don't fill in any pressures, the EN standard suggests that you should take into account the minimum internal and external pressure to take into account the charging and discharging of the silo. If you fill in 0, it will take into account these standards automatically. And of course, some silos might have an explosion hatch or something like that. If necessary, you can fill in the explosion pressure right here. Now for the live load on the cover. This is basically the same story as your pressures that you already worked on. The standard describes a minimum value which we should always take into account. So if nothing is filled in here, we will always take into account the minimum values described in the standards. Of course, if it is higher, please fill it in right here. Additional mass. There is also the possibility to add additional masses, depending on where they are located. For example, this could be on the cover, this could be on the top of the cylinder, or on the cylinder wall, for example, a hand railing or a ladder. Last but not least, the hopper outlet, for example, a vibrating bottom, which is quite common. Now that you've added the additional mass, we'll focus on the wind and snow loads. These are according to the European code. There are 2 ways to determine them. So first, we need to determine where the silo will be located. So click on the drop-down. To start, we've added a few different country options. However, if your country is not listed here, you can manually input it yourself if you click on User Input. In this case, you can use the national annex of these codes to look up the data you would need for that location. In this case, we will use the Netherlands. Next, you can look up the wind zone it will be located in and the terrain category. Note that next we need to enter the wind force coefficient. Standard is basically for a standalone silo. If you have a group or row of silos, you'll need to use the different wind force coefficients, this one right here. There's also a user input option where you can input a wind force coefficient yourself. Seismic loads. Last but not least, we need to enter the seismic loads. These should be according to the EN 1998 standard. This is a difficult one and depends on many different factors. If you need some more help, click on More Info. If you want to include the seismic loads, you will need to calculate the horizontal design acceleration, fill it in right here. Now that we've entered all of our information and all of our loads have been inserted into our project, we can click on Update. This will save everything that we just worked on. So at this point, you've calculated your geometry and you've calculated your loads, so it's time for you to check out our next tutorial on laminate thickness.